This is automation, today's way of manufacturing. This is the challenge for today, to meet competition and rising costs by moving step by step towards automation. Continuous automatic production, including automatic handling, automatic making, automatic inspecting, automatic assembling, automatic testing, automatic packaging of products in one continuous flow. The evolutionary step-by-step development is well underway today. Before the word automation was coined, the idea of fully automatic production suggested blue sky fantasy. Improvements in manufacturing seemed funny or fearful, depending on the viewpoint. And increased productivity, the source of higher wages and profits, was often overlooked. The trouble was that some people thought of automation as a sudden thing, a revolutionary idea. But it isn't. It began nearly 200 years ago when Oliver Evans put into operation an automatic grist mill. But Evans' basic problem was controlled power. He had to depend on water wheels and gravity. Before automatic could become significant, some entirely new type of power would have to be developed. A power far more flexible than falling water, or even steam. Controllable electric power, which could make automatic production practicable throughout industry, appeared in the 19th century. The step-by-step development of continuous automatic production was accelerated as early as 1919, when automatic blowing of electric lamp bulbs was begun at Pitney Glass Works in Cleveland. In 1938, 5 automatic machines were connected with transfers to form a continuous production line for machining and polishing flat iron castings. The idea of continuous automatic production, of automation, was here progressing from the processing of flowable materials like grain and molten glass to separate items like flat irons. And then, in the late 40s, developments in electric power and control helped to make possible a line for the automatic machining, honing, drilling, and boring of automobile engine blocks. This greatly increased productivity worked to the advantage of everyone, for this company today employs many more thousands of people than it did in 1947. This natural evolution in industry is developing automation as a way of manufacturing that can do much to improve our factories, products, and profits, and upgrade our workforce today and in the years just ahead. Progress in automation comes at a time when we will need it most. The United States, once an essentially agricultural country, has become the world's most important plant for the production of goods, with plenty of room left for food and fiber crops. Each person works for the other. All consume each other's goods and products. Our numbers are growing fast, but our demand for goods is growing much faster. At the same time, business is getting more and more competitive, for if demand is growing, so is supply as new competitors appear or old ones increase their efficiency. To hold or to build our share of the available market, we must cut production costs by applying the principles of automation. Manufacturing operations can be separated into 3 broad groups. First is the manual area, where physical effort is used to perform operations by hand or with the aid of hand tools. Second is the mechanization area, where manually operated, power-driven machines with varying degrees of control are used to perform one or more operations. Third is the area of continuous automatic production, where automatic machines are integrated with transfer devices and with controls to perform a series of continuous automatic operations. Materials handling begins in the manual area as a separate operation. In the next area, mechanization of materials handling is introduced. In the automation area, it is an integrated part of all operations. How automatic can we get? Except for process industries like oil and chemicals, the highly automated factory is still far in the future for most manufacturers. And progress comes from finding operations that can be upgraded, if only one step at a time. But the pressure of competition is bringing about step-by-step progress towards continuous automatic production, towards more and better jobs and greater profits. Automation principles, wherever they have been adopted, have proved their value in every way. First, automation pays for itself within reasonable time. Automation increases efficiency. Machines can be kept running longer at full capacity without shutdowns and delays for loading and unloading. Workers are upgraded. The emphasis shifts from manual to mental skills. Automation conserves manpower, a critical requirement as the demand for products grows far faster than the labor force. Automation improves quality by reducing manual handling, and there is greater opportunity for building inspection into the process. Automation increases safety. Machines move and lift. Human fatigue is greatly reduced. Automation reduces in-process inventories by the continual movement of materials. While continuous automatic production has not been entirely achieved, some industries are close to it. Bulb production was once a batch operation, but as early as 1919, development toward continuous flow began. In this glassworks, 46 types of bulbs are produced. Here is an operation high in the automation area. Glass biscuits are automatically produced by pocketed rolls turning against flat rolls. Chain conveyors automatically pass the biscuits to the blowhead. Finish blowing takes place in this rotating two-part mold. Around they go by way of a merry-go-round conveyor, continuously, automatically, on their way to the annealing oven. The plant capacity through the use of such automation as we have seen is an unbelievable 1,100,000,000 bulbs a year on a 40-hour week basis. Between 1910 and today, the cost of living index has risen 183%, but the cost of the 100-watt light bulb fell from $1.45 to less than a quarter. If the production methods of 1910 were used today, this 100-watt light bulb would cost over $4. During the same period, the population of the United States increased 80%, while employment in the lamp industry went up over 400%, or 5 times as fast. Here is the product of an automation process that has very wide appeal indeed. Cookies of various types produced in a continuous flow operation. The coordination of equipment speeds in this process from dough to packing is provided by adjustable speed DC motor drives. A cookie is more than something to eat. It is a manufacturing problem that has been linked. The customer is king, and highly flexible equipment is required to give him these varied delicacies. This machine can be set for many different varieties, from rotary molded cookies to extruded stock, like fig bars, which are cut after they have left the oven. Since all 4 types may be run in one day, the drives must change speed proportionately. Baking time can be changed, so the requirements for the next run can be met without upsetting relative adjustments on cooler, stacker, and packer for the remainder of the run. For cookies or cars, automation is paying off. The principle of continuous automatic. The blocks, beginning with the rough casting, put automatic in and out of more than 20 different machines, from speed electric drive broaches traveling 150 feet a minute through a total of 531 milling, boring, honing, tapping, and drilling operations. Production levels are maintained by specialists who replace all worn tools. In this operation, electric drives and controls contribute to higher production rates at lower production costs. These more elaborate examples of automation demonstrate to what extent the idea of continuous automatic production has been put into practice. It may not be economically feasible for every manufacturer to automate his entire production line, but important cost reductions can be realized by automating parts of a total operation. Few people realize that for all operations, including making, inspecting, assembling, testing, and packaging, the average falls at the low end of the mechanization area. This is the type of manual operation that can be seen in thousands of plants today. And this shows how soon a part manual, part mechanized operation can be upgraded in an automatic press line for producing series of operations within one line is here brought to a high degree of efficiency, as forgings like this are made into refrigerator compressor crankshafts. The forgings shuttle down a chute into the first machine. From this point on, 22 different types of operations are automatically performed in a continuous cycle. Upon completion, the pallets are dumped and returned to the loading station. The crankshafts are then transferred to the final grinding operations, which will result in finished crankshafts like this. There are numerous opportunities for moving inspection operations into the automation area. This manual inspection operation, once the very symbol of precision, is fast losing appeal as those who practice it lose money. Here is a machine for the automatic gauging and segregating of pistons. The pistons enter and are gauged and stamped for pinhole size. Undersize and oversize parts are rejected down a chute. The second station gauges the piston for skirt diameter and taper, stamps it, and transfers it on a belt conveyor unit for segregating into classifications. Capacity of the machine is 1,700 parts per hour. At times, automatic inspection may be combined with automatic making in one machine. This machine, equipped with automatic loading and unloading fixtures, continually measures its own work. When an error is sensed in the machining of a part, the tool is automatically repositioned to eliminate the error. Assembly, even today, is an operation that falls almost entirely in the manual area. But cost-conscious manufacturers in all industries are alert to opportunities for savings through automation. In the assembly of condensers, for example, this winding machine has greatly increased production. Significant progress has been further accomplished with this ingenious inline machine, on which 4 condenser parts, including cans, tubes, spring washers, and windings, are automatically assembled. In another inline operation combining further assembly and testing, each lead is gripped as the assembly passes, and the condenser is tested for capacity. If this test is unsatisfactory, the assembly is automatically rejected. Brass clips are attached, as they are made, onto the lead wires. The clips are then automatically welded to the lead wires. Here, great strides are being made toward the automatic assembly of electric motors. The motor parts are automatically conveyed from different areas of the factory to come together for assembly. The focal point is this assembly machine. The upgrading of the operation for automatic assembly here has helped to double motor production. While most is just stepping into the mechanization area, there has been progress. In this plant, ignition coils move on electrified conveyors, where they are tested and the results indicated by sight and sound. The coils moving in the conveyor are checked for presence by a photoelectric cell and pass against sliding contacts for successive electrical tests. Sound signals notify the operator of defective coils, which he removes and places in a reject chute. The testing of fluorescent starters has been accelerated by this automatic rotary machine. The starters, loaded manually into a rotating conveyor, are actuated by contacts traveling along a circular track. The starter lights a fluorescent tube within a given period of time, and a photoelectric cell detecting the light allows the starter to be passed. An unlighted tube calls for rejection. Limit switches set and reset relays, permitting proper inspection of each succeeding starter. In packaging, there are increasing opportunities to apply automation principles. Here, a group of machines automatically package nearly 13.5 million gallons of milk a year. The carton flats are formed and glued and then ejected into a wax tank, from which they enter a cooling compartment to harden the wax. The milk already pasteurized and treated is piped into this filling station, where carton after carton is filled with an exact amount. In this case, the capacity of the carton is 2 quarts. Folding and stapling the cover is another automatic process from which the cartons march endlessly to be placed in cases for delivery. The tiresome and relatively expensive work of filling packets with small items like screws or bolts has been eliminated by this packeting machine, which can turn out 24,000 packets per day. Small screws, bolts, nails, or parts are fed from the bowl vibrators, which can automatically start or stop the flow of items, affording exact control of the number of pieces in each packet. The double unit can pack 2 different items at once, ranging from 1/2 inch to 1 1/4 inches in length. Making, inspecting, assembling, testing, packaging. The small manufacturer may not be able to automate every stage of production, but there are numerous opportunities to upgrade one or more individual operations. The volume and nature of the product largely determine whether automation is feasible. Product design, standardization, materials and processes are the critical elements. Where a complete redesigning job is possible, the problem of automatic production can be simplified. In the conventional chair, there are a variety of styles. This chair is made from shaped pieces, in many cases with the aid of hand tools, and finally assembled by hand. Here is a chair of modern design, which is the product of more mechanization. The parts are machine formed. They still require some hand finishing and hand assembly. Now, here is the chair designed for continuous automatic production. A fresh approach to chair design is taken. The hand operations are designed out, and the material is molded with integral color and perfect surface. The higher we progress up the steps to automation, the more the product must be designed for continuous automatic production. Of course, there are always exceptions, and customer preference sometimes calls the turn. For example, customers would not go for machine-cut pretzels. Traditionally, pretzels were hand-tied, and some experts said it was impossible to develop a machine to do the same job. But a way has been found to accomplish the impossible. With pretzel tying machines, which can produce 50 hand-tied pretzels a minute. A battery of 16 of these pretzel tires can turn out up to 384,000 of the twisted delicacies in an 8-hour day. Of course, pretzels are standardized and produced in great volume. Standardization for volume production is one of the key factors in automation. With standardization, volume production, if it cannot be applied to the product itself, may be applied to the parts. The 4 legs of the mechanization area chair might be produced automatically. In low production items such as large motors, the production of the laminations may be automated. In the jet engine, the number of turbine blades is high, and here again, volume offers the possibility of automatic production a step below the product level. There is a place for automation in every industry, large or small. The extent to which it can be applied economically is determined not by the size of the business, but by the volume and nature of the product. In any operation, electricity is the essential ingredient of automation. As manufacturing operations are upgraded through the mechanization area and into the automation area, the vital importance of flexible electrical equipment grows. Equipment like control panels, limit switches, adjustable speed drives. These and many other standardized electrical units available today contribute to automation. More specialized equipment is available where it is needed to automate extremely difficult operations, such as turning and facing cuts on irregularly shaped jet engine parts. The machine is a vertical turret lathe equipped with 2-dimension tracer control. A signal is generated in the magnetic tracing head by the displacement of a stylus against a template. Sensitive electrical equipment takes the low power signal from the electronic panel and amplifies it to the power level necessary to operate the feed motors. In this case, automatic control is a necessity, since the cost of manufacturing such parts without tracer control on the machine would be prohibitive. Another type of control is that made possible by record playback. Here is a mill designed for the machining of integrally stiffened airplane wing skins. The use of record playback control in this operation is expected to double production. After a part has been produced using a combination of manual and electric control and the action in the form of signals from Selsins recorded on magnetic tape, the tape is played back for automatically producing successive parts. The tape programs the machine's operations. Still another type of control reads punched cards and automatically positions all motions on such machines as this turret press, which cuts production time in half. Sensing position with Selsins, the control detects and interprets punched card information for the direct current motors which drive each motion. Combinations of electrical controls and drives like these now in use, as well as a great many others, can raise many of your operations to the level of continuous automatic production. Progress towards automation is most often a step-by-step procedure. Much standard equipment in use today can be adapted for automatic production. transfer equipment can be added, as with this punch press. And many new machines can be purchased equipped with transfers, or designed for their addition, like this machine. There are also machines designed for special applications, but which often include a number of standardized units. There are many other types of machines which can be adapted to this way of manufacturing. Automation, continuous automatic production, is a program for today. For it is today that the average of all manufacturing operations, making, inspecting, assembling, testing, packaging, falls in the low mechanization area. And too often, grunt and sweat methods like this account for as much as 50% of production costs. In some cases, practically an entire production process may be automated. But for the most part, the challenge of today is for management and engineers, men with vision, enthusiasm, and imagination, to tackle the job at hand and improve their operations step by step. Any of these steps is possible, and possible now. Anyone who makes anything can find opportunities to apply the principles of automation to his business. And as we respond to the challenge, the electrical manufacturer and the machinery builder stand ready with the equipment and the engineering skill to help your business meet the competitive challenge of today.